In this video, we're talking about how to use the gradient vector to find the equation of a tangent plane. And in this particular problem, we've been given the function x to the fourth plus xy plus y squared is equal to 19. We've been asked to find the equation of the tangent plane to this multivariable function at the point P, which is the point 2, -3. So the first thing we need to remember is that the equation of the tangent plane is going to be given by this formula. Z is equal to a times x minus x1 plus b times y minus y1. So a and b are going to be the slopes in the x and y directions respectively. x1 and y1 are going to come from our point P. So really what we need to do first is we need to find the gradient vector, gradient of f of xy, because once we have the gradient vector, we can identify a and b, which are the slopes in the x and y direction. So to find the gradient vector of the function f at the particular point we've been given, the first thing we need to do is find partial derivatives, first order partial derivatives of this function. So first, let's go ahead and subtract 19 from both sides so we get everything on one side. Then we can call this function f of xy is equal to x to the fourth plus xy plus y squared minus 19. And now we can take first order partial derivatives. So partial f partial x, or the partial derivative of the function f with respect to the variable x, is going to be, and remember when we take the partial derivative with respect to x, we treat x as the variable and y as the constant. So the derivative of x to the fourth, that'll be normal, that's 4x cubed. The derivative of xy, well, y acts like a coefficient on this first degree x variable here. So the derivative is just going to be y. So we'll go ahead and say plus y. The derivative of y squared will be 0 because there's no x variable involved here. Y is a constant, so y squared is a constant, and the derivative of any constant is 0. Similarly, the derivative of -19 will be 0. So now we need our partial derivative of f with respect to y. For x to the fourth, we'll get 0. For xy, we'll just get x. And for y squared, we'll get 2y. -19's derivative will be 0. Now, with our partial derivatives, we can say the gradient of the function is going to be, and we'll plug our partial derivatives into this formula here. So we'll have 4x cubed plus y, comma, x plus 2y. Now, if we want to evaluate this at the point of tangency, the point 2, -3, we'll say the gradient of f at the point 2, -3 is going to be equal to, and here we just plug in 2 for x and -3 for y. So what we get is 4 times 2 cubed plus a -3, which is just -3, comma, 2 plus 2 times -3. And when we simplify, what we get is 8 times 4 is 32, 32 minus 3 is 29, and then here we have 2 times a -3 is a -6, 2 plus a -6 is like 2 minus 6, or -4. So these values then are actually going to represent a and b from the formula for the equation of the tangent plane. So we had these values here, a and b. Well, those are going to come from these numbers we just found here, a and b. So we're going to plug those into our equation. We're going to get z is equal to, a we know is 29, multiplied by x minus x1. Well, x sub 1 comes from the point P, so we take the x value there and we say -2. Then we're going to say plus b. Well, b is -4, so plus a -4 is like -4, multiplied by y minus y sub 1, which comes from the point P, that's -3. Well, y minus a -3 is the same as y plus 3, and so now we just have to simplify this. We'll say z is going to be equal to, if we distribute the 29, we get 29x minus 58. If we distribute the -4, we get minus 4y minus 12. If we combine like terms, then we can say that the equation of the tangent plane is going to be z equals 29x minus 4y, -58 minus 12 is going to be a -70, so we get minus 70, and this is the equation of the tangent plane, which we found using the gradient vector.